Here we go. Okay, so pretend that I'm not Mrs. Talbot. Pretend that I'm Leanne Talbot, and I'm taking my AP Stats Chapter 8 test, and I sat down, and this is my FRQ here. Okay, now, first thing I would do was say to myself, is this a one sample or two sample situation? So it says, you toss a coin 30 times, and it lands on heads 60% of the time. Calculate a 90% confidence interval for the actual proportion of the number of heads. God. One sample or two samples? One. Okay, now it sort of told you that in the title of the worksheet, but you won't have that luxury on a test. So the first thing you do is decide one sample. Okay. And then what I'm going to do is I'm going to go through and figure out the things I need. I need that. I need that. I need that. I need that. And then Nami's like, you're speaking my language now. Highlighting the important stuff. She's so good at that. It's a strength she has. Okay. Now, this is a moment I'm going to ask you all, everyone in here, to not be lazy. And I know, can't believe you're asking me that. And make sure that we type the calculations in on the calculator. Don't just watch me do it, and don't just have your group do it, because the biggest problems right now that I've been seeing are not conceptual, they're just calculator stuff. So we want to make sure that we practice that multiple, many, large amount. Okay. If you toss a coin 30 times, lands in heads, calculate a 90% confidence interval. Okay, so state. State means you're stating what you're going to do, and it says calculate a 90% confidence interval. So you just start writing that. 90% confidence interval for P equals. Okay, now I always write the true. This particular problem says the actual. I don't care if you write true or actual. It's up to you. Either way. This is also a really good time to practice writing small. Okay, that's it for the state. Any questions about what to do there? So say, okay, the first thing I do on all these problems is write the percent confidence, and then hopefully the rest of it will start to like roll off. What I mean by roll off is just like come out of your memory. Okay, any questions about the state? What we do for the state? Not the state of California. Okay, plan. Plan. You do two things in the plan. You say what you're going to do, which is the plan, and then you check the conditions. This is a one sample Z interval for P. You only know two different inference methods right now. You only know one sample Z interval for P or two sample Z interval for P1 minus P2. Those are your only two options at the moment. Later in the semester, you'll have more options. Okay. What are the conditions? What's the first one? Random. This problem does not say random in it. So what do? Do we give up and walk out? No. Assume, yeah. Much as we would like to just leave it there and say no solution and walk away, not the land we're living in.
No, if it, once it like shows that it's like not random, it's just gonna change random every time.
Yep. It's going to be random every time unless it's an MCQ or something that says what's wrong with this picture. And then you look for randomness. I believe there's one of those in the, or one or two of those in the AP Classroom MCQs where it's like literally asking you about the conditions and you have to check for randomness. Okay, what's the next condition? Nice. N equals 30. That's probably true. If you were to toss it forever, you'd probably get more than 300. Okay. Great. Okay, what's the formula for large counts? Beautiful. Okay.
But
Okay. N is 30. P is 0.6. And this isn't really P, it's P hat, but it's our best guess, so that's what we use. Oh, by the way, I bought this from a different teacher. That's why it says example 2 and then example 4. Um, I was too lazy to take those off, so thank you. Okay, now this is what I don't want to see. Let me tell you some stuff I do not want to see on a problem like this. For random, I do not want to see random check. I don't want to see that. You have to actually say something. Okay, you have two options. You have assume if it's not in there, or you copy the language off of the problem, but you don't just say random check. Okay, here's another thing I don't want to see. I don't want to see this and check, and then you leave me to do your arithmetic. I want to see the actual numbers. Does that make sense?
yeah.
Okay, do. What's that, Jamie? You love stats?
Yeah.
Okay, so to do a one sample Z interval for P, you need three things. You need P hat, which in this case is 0.6. Does that make sense? Do you see where the 0.6 came from? Okay. You need Z star. Okay, so everybody, we're going to practice finding Z star. Now, this one is 90%. You might have it memorized. I do because I'm a nerd, but okay. Second, make yourself type it. Second, vars, inverse norm. Now, if you're a lucky duck, it's already in there. Okay. Now remember, the star means absolute value. So then I always round the 90% one to 1.645. So positive 1.645. Here is a moment where you get to be lazy. You don't have to write the calculator command on your test or your AP exam. You can just write Z star equals 1.645. Yes, honey. Yes. Excellent question. Okay, now we go to the formula sheet. So we're on the top row on the back. So flip your formula sheet over to the back. We're on the top row. Did you? Well, is it not where you left it? Anyway, so we're over here, standard error of sample statistic. So square root p hat times 1 minus p hat over n. So square root p hat 1 minus p hat over n. Um, you mean instead of this? What? It should be S. Hopefully, what I'm hoping is that you'll go right here and you'll see it says standard error of statistic right there, and then you look at the standard error of statistic right there. I just have it in my head as it being standard deviation, so. Okay, now calculator, everybody. Square root 0.6, 1 minus 0.6. Do you need to put the zeros in the front? No. I don't know. Again, another thing I've just trained myself to do, I guess. Do it all in one calculator motion. 0.6 times 1 minus 0.6 over 30. And I got 0.089. Make sure that everybody has the same thing. 0.089. Do we get it? Okay. Statistic plus or minus critical value times standard error of the statistic. Statistic plus or minus critical value times standard error of the statistic. Do you know where you can find that on the yellow sheet? Okay, 0.089 times 1.645. Okay. Any questions about the calculations? Okay. Conclude. We are 90% confident that the interval of 0.454 to 0.746 captures. Okay, and then what you do is you start cheating off yourself. So you go up here to after P equals Okay, so for this particular coin, if they were to toss it forever, you would get heads anywhere from 45.4 to 74.6% of the time. And you could be 90% confident about that. Okay. Any questions at all about this FRQ here? I think it just comes down to memorizing the pieces. Okay, now go to the bottom. What does a 90% confidence level mean for your results in example 2? This is the bad sentence. Yes. Okay. Now, I like this one. This one's a little bit different because if you say over many, many samples of the same size, n equals 30 or whatever, it doesn't make any sense because of the context of the problem. This is not like, so you have to think of like sets of 30 tosses being the sample. Does that make sense? So this is what I would say. Over many, many sets of 30 tosses. Over many, many sets of 30 tosses. If we calculate 90% confidence intervals for each set. Okay. What's next? About 90% would capture the proportion, Mrs. Talbot, proportion. Okay, that one is done. Flip to the back, please. Okay. Women diagnosed with breast cancer were randomly assigned to either undergo surgery in an attempt to prolong their life or forego surgery. My goodness, this is a depressing FRQ. Among the 347 women who had surgery, 16 eventually died as a result of their cancer. 31 of the 348 women who didn't have surgery died of cancer. Yikes. Mrs. Talbot, you chose a really cheery FRQ here. Create a 95% confidence interval for the difference in death rates. Okay, so I'm sitting down to take my test. First thing I do, 1 sample or 2 sample. Okay, 2. And you can tell because of all the numbers, but you can also tell because it says difference. So what do I want from this? I want randomly assigned. Okay, so 95% confidence interval. This one is a difference. So you write for P1 equals P2. P1 minus P2 equals the true difference in death rates. Okay. Now, the one thing we have to keep in mind when we do a problem like this, we have to say which order of subtraction we're going to do. They didn't tell us, but surgery was mentioned first. So I'm going to say surgery minus no surgery. My G's look like Q's and it's making it look like the wrong word. Okay, anyway. Plan. Q sample Z interval for P1 minus P2. Again, you only have two types right now in chapter 8. One sample Z interval for P or two sample Z interval for P1 minus P2. Random, randomly assigned. Nice, good job, nice memory. 10% does not apply. Because it's an experiment. So 10% condition only applies when there's random sampling involved. If there's an experiment with random assignment, you can skip that, which is great. I like to skip it. To be honest with you, I look for problems that say random assignment because that means I get to do a tiny bit less. Okay, this is probably going to be annoying. Oh, no, it's not because they gave me successes and failures. Excellent. Okay, so 16 is greater than or equal to 10. 340. What's 345 minus 15? 331. Dang. 331 greater than or equal to 10. 31 greater than or equal to 10. 337. What's wrong? Oh, yeah.
No, she did it right. Yeah.
I need more tea apparently. Okay, but do those numbers make sense to you guys where I got them from? Like, not the fact that the 317 was wrong, but do you see how I got the four of them? Okay. All right, check. Do. Okay, P hat 1 minus P hat 2. So P hat 1 is 16 over 347. P hat 2 is 31 over 348. I like to find these separately because I need them later for the standard error. So it's 16 over 347. Thirty-one over should I be concerned that that's negative? No. It happens. I'm hoping that that's the one that you have memorized. If you have any of them memorized, that should be the one. That's the one we use the most. If you don't have any of them memorized, it's fine. It doesn't matter as long as you know how to do it on the calculator. Okay, now two sample. I'm right here. Right, this guy. Okay. So if you're gonna mess up on the calculator, it's probably gonna be here. You want to type it in all at once. So square root 0.046, 1 minus 0.046. Make yourself do it. Over 347 plus 0.089. 1 minus 0.089 over 348. Zero point zero one nine. Did anyone get anything different? Did I do it wrong? You gotta watch me over here. It could be anything with me. Okay, so negative 0.043 plus or minus 1.96, 0.019. Statistic plus or minus critical value times standard error. What's wrong? 0.019. 0.43. Whoo! 'kay, again, wonky numbers. Don't be freaked out by that. They're not really that wonky. This is negative 8% to negative 0.6%. It's not that weird. Okay, how does the conclusion start? We are. Okay, then you want to say your answer. The interval captures. Okay, and then come up and start copying off yourself the true difference in death rate. Okay. B, based on the interval, what can you conclude? Okay, so this goes from -8% to -0.6%.
Yeah.
Correct. Okay, 0 is not in there. Okay, so that means that there's not a possibility of no difference. Means there is a difference. Okay, then you say, okay, both of the high and low numbers are negative. My entire interval is negative. Okay, so because our entire interval is negative, okay, so scroll up. Now we have to think about what that means. It means that this number is bigger than this number, which means that the no surgery was bigger than the surgery. I just put this little thing there for a visual. You don't have to write that, but does this make sense? Since it was negative, that means the second number is bigger. If the second number is bigger, the second thing was no surgery, so higher death rate for no surgery, which kind of makes sense, sadly, for the terrible, terrible context of this problem.